really recording. Okay, got it. I've done a lot of education about soils, and I really enjoy educating. I educate from kindergarten through to adults. I've got a workshop coming up at Lotus Land in April, compost tea party there. So I think that's April 24th. So you could look up the Lotus Land website. But this is me teaching actually Nordhoff High School students. And, just looking at soil under the microscope, charismatic microfauna. Oh, let's see if my screen will help. Here we go. Okay, we also do community soil testing workshops. This is my good friend, Bill Palmisano, who's based in Santa Barbara. He was one of the people that really introduced me to Soil Food Web and to the work of Elaine Ingham, who is my direct teacher. And here's Elaine on the left-hand side. I want to acknowledge Elaine and also Vandana Shiva, one of my teachers. You can see can you guys see the whole screen, or are you obscured by you can see the whole screen? Okay, great. And also, sorry, Bill Mollison. And Bill Mollison was the founder of permaculture design. And I was very fortunate to take a course with Bill Mollison in Ojai in 1997, and it really brought a whole bunch of things together for me. So thank you, Bill. This image is from the Kiss the Ground movie, and the folks who made Kiss the Ground, Josh and Rebecca Tickell, are based in Ojai. And the point this makes is that plants sequester carbon and they put it in the soil. And a lot of it, they obviously build their bodies out of it, but there's a lot of it's going into the soil. And so when we picture trees, we tend not to picture their root systems. But this is where the extensive amount of biomass exists on our planet, is actually in the soils. And the big picture, as Diane was saying, is that regenerative care of our soils is a nature-based climate solution. And so participating in organic agriculture and composting, these are actions of solutionaries. And I really think that they give us hope in this time of climate change in the Anthropocene. So I will just mainly show pictures, but this one has a little bit of text, and it's important to give the kind of basis for how soils develop. And as you get a development of plant communities, what happens is that soils go from being bacterially dominated on the left-hand side here to being more fungally dominated when you have more perennials in the landscape. And we're learning more and more about the relationship that plants have with fungi. Pre-1996, it was pretty much viewed that all interactions between fungi and plants was pathogenic. And now we have an understanding. It was only in 96 that we had the first inklings about the synergistic relationships that exist between plants and fungi. And of course, there's a lot more information and research being unveiled about that all the time. One of the key folks that have really popularized that, Suzanne Simard, will be speaking in Santa Barbara on May 1st. And her book, Searching for the Mother Tree, is a classic read, a crossover between being a good read and also an understanding of the science of mycorrhizal interactions and mediation of interactions between plant communities. So the key thing from this image is just to realize that if you're dealing with annuals that are fast growing, shallow rooted, seed quickly, they like bacterially dominated soils. If you're dealing with plants that live for more than 3 years, that are hardy, woody perennials, then they are more than likely going to have a complex relationship with the fungi in the soil. This is just a cross-section through a soil profile. And what's important to see in this is the top layers are organic, that they have carbon as their components. And really, when you when you're talking about regenerating soils, what you're talking about is increasing the soil carbon content. And that's the takeaway from this is what if you're trying to increase the health of your soil, you want to increase the soil carbon content. And the simplest way to do that is to plant plants which pump carbohydrates into the soil. We can do it by adding mulches, certainly by adding compost, by adding biology, but by putting plants in the soil, that is the best way because they take CO2 out of the atmosphere, they convert it into carbohydrates, and they inject it into the soil. So, I wanted to, I'm going to bring this image back, but I'm not sure if you guys know who this is. Generally, when we see this person, he's got a big white beard, and this is probably one of the people that, if I could go back in time, that I would choose to meet. This is Charles Darwin, age 7, and his last book was on earthworms. And what was very interesting is he was writing this before industrial agriculture had come on the scene. And he found that regardless of the underlying geology, that everywhere he went, there was an overlaying area of dark soil that was created by the action of worms. And so really the encouraging worms of any kind, in my mind, is a good thing because they create the air spaces in soils. And this is important to realize is that where biology occurs in soils is in the air spaces that are coated by moisture. And so if you can imagine yourself getting into soil as some kind of microbe yourself, then where there is space for you to move and there's water for you to live off, that's where you're going to live. That's where you're going to eat. That's where you're going to excrete. That's where you're going to reproduce. That's where you're going to die. And the biology in the soil is key to plant life. You can't separate plants and soil. They're together. Now, when I see soils, I like to see soils covered. In fact, one of the adages of regenerative soils is no bare soil. And so I love to use wood chips. And wood chips, not all wood chips are created equal. It's important to recognize that the best biological sourced wood chips are from small diameter wood, and it's usually native plants. So small diameter wood they call ramial wood chips, and that's from branches that might be 2.5, 2 inches wide or less. And they've got a lot more unpolymerized lignins. They're not woody. They have a lot of the material that then will be humified and turn into soil. And of course, when I'm looking at wood chips, I want to see these fungal strands, these mycelial mats developing on the wood chips. And these mycelial are full of threads that are the actual bodies of fungi. So the hyphal threads are carbon tubes. They themselves are carbon, and they are breaking down, the saprobes are breaking down wood and making soil. So this is one of the important roles of fungi as a decomposer. Now, if you were using, I told you there, if you use native, if you got fruit trees and you want to mulch them using like coast live oak, small trimmings of coast live oak, that's going to be great because it's going to break down and form soil. The other extreme would be trunks of eucalyptus, which will never break down because there really isn't the biology in the environment here that's adapted to it. However, if you want to use those on your pathways to suppress weed growth, then yeah, go ahead. So, wood chips have their different places in your landscape. But generally around plants, I'm going to use as much as possible native wood chips and of small diameter wood. The folks who trim the power lines, they're a good source of small diameter wood. Now, here we've got the classic image of a pine tree with its ectomycorrhizal associates in the root system. And here you can see that the root system has just been increased immensely by the connections with fungal hyphae. So this plant is able to to collect a lot more of nutrients from the soil, and it's also able to collect nutrients from the fungi themselves, which can break down inorganic compounds to make minerals available, and they can break down organic compounds to make those nutrients available too. So this mycorrhizal association, as well as the saprobes, the decomposers, this is where you have the connectors of the fungal world. This is an arbuscular mycorrhizae. This is under light microscope, but these arbuscular mycorrhizae are, they're called arbuscules because they look like little trees, but along the bottom is a root, and then coming out of it is this mass of fungal hyphae that just, you can see how much surface area that creates for absorbing nutrients and passing those on to the plant. And then the plant is giving the fungi food as well. So it's an exchange system there. I wanted to show you this, one of my favorite mycorrhizae. This is colloquially known as dead man's foot. It's actually called Pisolithus, and it's a puffball. It's not a very prepossessing fungi. Some people actually call it a dog poo, the dog poo fungi, but it is the one that's the mycorrhizal ally for coast live oak. And 80% of the living things in our environment are plants. And of those plants, the most common one in our area is coast live oak. So the understanding that these are the mycorrhizal allies of your oaks are very important if you're planting oak trees. And so when I take these, I harvest these and I grind them up, and the spores, which the whole fruiting body there is composed of spores. The spores are about 7 microns across, and those are like smoke. So they're very, very tiny. But if you coat acorns on them, then they're right there when that acorn is sprouting. So this is Pisolithus arisis, dead man's foot. Now, another action that fungi do is that they hold together the particles of soil. Soil beds are held together by fungal hyphae. So on the left-hand side, that you can see there, that's soil that is aggregated. There's air spaces in there. It's being held together by bacterial and fungal glues. On the right-hand side of this image, this is a scanning electron micrograph of a soil bed, and those lines are individual hyphal threads holding together the soil. And so what that does is it creates air spaces in between the particles. And so again, another adage of regenerative agriculture is no-till. And what happens when we till is that we break up all of these aggregates. And it may seem that after you've rototilled an area that, oh, the soil's all nice and fluffy, but actually what happens is that it compacts because you've reduced the amount of airspace there is in between the soil particles. And you've also reduced the ability of moisture to get in there. Regenerated soils absorb, they really are a sponge. They're a carbon sponge that it can absorb water. So as much as possible, regenerative procedures and regenerative agriculture tends to focus on perennials because you don't have to till. This is a fluorescence micrograph of a fungal hyphae, and it's been tagged with a fluorescent tag for glomalin. And glomalin is the glue that glues together soil particles. 30% of the carbon that's in our soil is actually the glues on the surface of fungi. And so really you can see the importance there of fungal construction of soils. And this is something that develops over time, but we can very rapidly delete it by tillage. This is a scanning electron micrograph that's been colored. This is a root hair. And this is where the interaction between plants and soils occurs, is in the rhizosphere. And in this area, that's where that root is releasing carbohydrates into the soil. And that's where the biology in the soil will aggregate, because that's where the food is. And that it will only aggregate there if there is actually biology in the soil. But when we look at this image, and this was given to me by Gabe Brown, who's the star of what is it, the new Kiss the Ground movie, which I haven't seen yet, actually. Was it greater? Was it Common Ground or Growing Grounds? Growing Grounds.
Common ground.
Yeah, Common Grounds. So again, this is liquid sun. It's being pumped into the soil and released in an area that then can feed biology if that biology is there. So this is the thing that composting brings, is we want to add biology to our soils. Now, this is a micrograph. This is video that I've taken of compost. This is one drop of compost. And the things that are zipping around there are flagellates. They're single-celled protozoa that have a flagella that makes them mobile. The line in the middle is a fungal hyphae. And you can just see the amount of life there is here. The circular things are testate amoeba. So these are amoeba, these are flagellates, and this is fungal hyphae. This is the sort of thing that I want to see in healthy compost. And if you've got one drop and it's got this much biology in it, if you're adding pounds of compost, or you're making compost tea where you're adding gallons of compost tea, then you have a lot of biology in there. There's a lot of biomass. This, by comparison, is a ciliate. You can see perhaps as it moves around under higher magnification, the cilia at the end here, and that's how it's mobile. These are found in anaerobic conditions. And when we're making compost, we really want compost to be, I'm going to stop it here. We want compost to smell sweet. And this is the important thing about making compost, is we don't want it to go anaerobic. And there's a reason that we move away from smells like poo or dead bodies or rotted food. We move away from those smells because they are associated with pathogens. And so it's made sense. The people who didn't move away from them didn't survive as well, right? So we move away from bad smelling things. And that's what happens when something goes anaerobic and all the available oxygen has been used up and they only have anaerobic organisms left, and those tend to be more pathogenic. So we want to have a balance in our composts, particularly of nitrogen, of food source, and carbon, so that we're not creating huge populations of bacteria that use up all the available oxygen, and then the whole thing stinks and goes anaerobic. Just here, this shows a little bit of the complexity of the soil food web. There is a ton of life in a healthy soil, all sorts of variety, from the organic residues at the bottom all the way up to macro invertebrates that you can see with the naked eye. One of my favorite things to do with kids in gardens is to sieve compost, and they're producing soil, but really what they're interested in is catching the bugs. And you can then classify them. You can show how many legs has it got? Does it have any legs? What do you think it eats? All of that stuff. So you don't have to teach children that soil is alive. They are there pulling the life out of it. And the best age groups I do that with is like kindergarten through third grade. But I've also done it with middle school and high school kids and adults. So it is pretty fascinating to sieve your compost. Here's just a characteristic of living soil versus dead dirt. On the left, you can see living soil. You can see the color there. The color, there's around about the color of 70% dark chocolate. And that's the humates in it. Humification has occurred. And I actually add humic acids to my waters when I'm making compost teas, because it complexes the chloramines that are put into the water. If you've got well water, you don't have to worry about that. But on the right-hand side, you can see the light-colored soil that's much more sandy. You can tell that that's not going to be able to store water. It's going to be compacted. It's not going to have as much biology in it. It's not going to have as much nutrition in it. So yeah, again, this just emphasizing the difference between living soil and dead dirt. And what happens with dead dirt is you get runoff because water can't infiltrate, then it runs over the top, and then it causes erosion, and then you lose your topsoil. Now, really, I want to encourage you and to be regenerative with your soils, but there's also the things that we want to avoid, which are problematic with soils. One of them is tillage. Now, industrial agriculture, this is not an uncommon scene that we see in Ventura County, clouds of soil being blown away. And it's ironic. It's not really about care of the soil. It's about short-term profit, right? That's what that's about. But when we, oh, I thought I put in another image. Huh. Oh, well, maybe I have an image of, I thought I'd put it in, maybe it'll appear later on, of the Dust Bowl in the 1930s. And we should not forget about that when there was a great loss of topsoil, and that was because of tillage. And so we're in certain areas beginning to learn that, well, we can't just till because we're losing our topsoil. Another thing that happens, this is classic, is about the aesthetic. And so people want to clean things up. Whenever I hear that, clean that up, that means reduce soil carbon content. That means make your soils less healthy. In this instance, and this was just actually behind a branch of my bank in Ventura, I just took a picture because you can see the water is not able to infiltrate. And probably every week somebody comes there and scrapes away all of the organic layer on top. And that is not uncommon we have to get over this over management of our soils because of an aesthetic about cleaning leaves up in particular. Another thing that happens is compaction. Now, probably in your gardens, you've not got compaction like this. This is actually at lotus land. But what you probably have is this kind of compaction. And it should not be ignored that standing and walking around your plants is squeezing the air out of your soil. It's reducing the amount of air spaces in your soil for water to infiltrate, for biology to exist. So compaction is really anathema to plants. And I've certainly been with star gardeners, and they are very protective of their beds, plant the plants and then walk away from them. And often you'll see in gardens that compaction is occurring because of regular movement of people walking around gardens. Obviously, if you're driving, it's going to be compacting, but walking is a compaction too. You guys get it. Organic agriculture is good to support. I really encourage people not to buy non-organic strawberries. It's hard to think of this as being your friendly local farmer when he's spraying toxic pesticides on the crops. And it's the farm workers who are the most at risk. So just to summarize some of the things about building healthy soils, I really like Gabe Brown's work. So there's some great YouTube stuff of him. Of course, he's featured in our latest film, but least amount of mechanical disturbance, no till. They talk about armoring the soil surface, covering it with mulch, but cover crops are better. And really, locally, the Apricot Lane Farms, who they had the film Biggest Little Farm, that inspired so many people to pursue regenerative agriculture in their own home gardens. And the biggest challenge for those guys there was getting the cover crops to establish. And it took them, and they took over really chemically defeated soils. And it took them at least 3 years to get cover crops to actually take. So it can take a long time, but it's realistic to think about a 3-year transition time from chemical to biological. And that's the sort of transition that we want to foster. Plant diversity is so important. And this is, again, one of the problems with agriculture is that we find it hard to make money out of diverse amounts of crops. So small farmers are the ones to support there, and backyard gardeners or front yard gardeners, So there's a lot to be said for Diane, your introduction there about the importance of home food growing, and school gardens, another great one. Keeping roots in the ground as long as possible. If you can harvest and leave the root in the ground, then it will break down and it provides a pathway for biology. And then animal impacts, moving animals across the landscape. If that's practical, that's great. And the animals that I bring in are the soil biology. I don't have the ability to move, generally to move goats or chickens across the landscape. But in certain places, that is a way that Joel Salatin, for instance, is somebody that's really promoted that in agriculture, where he's moving cattle and then he's having the chickens follow and then he's seeding, So summarized here, you're wanting to increase soil carbon content, no-till, chop and drop, leave the biology there, leave the leaves. That's why they're called leaves, right? Leave them there, and adding mulch. This is so. When we talk, there's so much information about that's really skewed in soils about chemicals that it's so common to hear people talking about NPK, right? But nitrogen is important because we need it to make proteins. And generally, nitrogen is added in agriculture as a purchased fertilizer. But in this instance, this is an ag operation where they have avocados and they have climate buffering. These are nitrogen fixing trees, Tipuana tipu trees, interplanted. And they actually, the climate buffering protected these trees in the heat. We had these heat island effects in Ojai in 2018, where it was 100 degrees by 9 a.m. and it got up to 118 and the avocado crop failed. But in this instance, the trees buffered the temperature change. So as we are thinking of ways to tackle climate change, then again, tree planting and climate buffering, it's worth looking at. And nitrogen fixers, there's native nitrogen fixers, ceanothus, redbud, lupins. There's nitrogen fix above every acre of land. There's 36,000 tons of nitrogen. You don't have to buy it. Plants will put it in the ground for you. So if I'm trying to build soil around perennials, I am going to put wood chips in there. I am going to add mycorrhizal inoculants. The fungal foods that I use are whole fish, feather, kelp, soy, alfalfa. I buy a meal called Landscape Mix from Island Seed and Feed in Goleta. But you can also use composts and compost extracts and compost teas. And so I'm going to talk a little bit about that. Here, I'm just going to give you a tour through making compost piles, how I do it when we're making a cubic yard of thermal compost. So here we go. We're going to do an overview of building a compost pile, and we're trying to build a fungally dominated compost pile. But we are going to start with some of the stuff that's in our worm bin. Here's just to show that we have some worms, and over here is too chunky for the worms right now. So I got all of chunky stuff in here, and we're going to include that. This is a food we put in. This is a landscape mix. It's alfalfa, soy, fish feather, and kelp. And then here we've got, this is from the green waste from Ojai Valley Organics. This is some rotting wood from the orchard. It's probably citrus or avocado. Some of this might have native woods in it. And then here we've got filters and waste from the coffee roasting company. And here we've got the spent compost tea bag. This is finished compost with foods that's been in a brewer for 24 hours. And then here we've got pulp from Rainbow Bridge juicing. So that yeah, and the pulp, that is a really great food for worms because it's been pre-digested in many ways. So if there's ever any juicing in your neighborhood, then ask them what they do with the pulp. But when you're using that pulp, that's going to be pretty much a bacterial food. And so what you saw in there was that I added a lot of things that were actually fungal foods. And so what we're doing there is we're building a pile, and we're trying to build a pile that's about a cubic yard, 3 by 3 by 3. And as we layer it, we're just adding water. And in this instance, because it's from Casitas, we add humates. So there's humic acid in that hose and sprinkler. But again, it's layering about equal amounts of green and brown to make our compost pile. And it's good to have friends to help you make your compost pile. It's a good community building event. And in fact, a lot of the work that we do is about community composting. So paying attention to the temperature.
March 1st, she's ambient temperature, just 50, 58, 56, 58. So we'll see. We're hoping that she'll get it to like 140, 145 maybe. We'll monitor it. We'll turn it at least 3 times, and we'll see what we get out of Rapunzel.
Oh yeah, so we name the compost pile. It's kind of fun. You relate to your compost pile very differently if you give it a name. And then it gets hot, 160 degrees. That's because of bacterial action. That's biology that's making that heat. A basic error some folks make about composting is that they think they've got to put it in the sun to heat it up, and that'll dry it out. If you see Argentinian ants in your compost, that means it's too dry. So keep it moist enough that you can pick up a handful and squeeze 1 drop of liquid out of it. Then it's about 50% moisture level. And if it gets up to above 160, you probably want to turn it pretty quickly. Because if it gets up to 185, that's when you get the alcohols, the flash point of alcohols that are produced in there. And that's when you get fires. But that's never really happened in small composting operations. Here's compost that's finished and being stored. This is Corey Wells, who just retired from Lotus Land. So Lotus Land, 35-acre premier garden in Montecito, and their plant healthcare program is based on compost. And it's not necessarily the most photogenic thing to have your compost pile on there, but it's got the biology in it, and they're spreading that around their plants using compost teas. And this is their rose garden. Their rose garden is pretty exceptional. They use undiluted compost tea on that every week. And the quality of the roses is very high. And they're in a marine area, so they're much more prone to, I'm not a rose expert, but they certainly have diseases. What is it? Powdery mildew and black spot. These are very common rose diseases. And they're very tightly packed together. So they're doing a great job with their, it's a beautiful garden, that's for sure. So thermal composting is one thing, but another way to do it is with worm bins. And these I built these worm bins. These are, this is at a community garden. These are what we call continual flow worm bins, and they're open at the bottom. And they have a network of ropes across them. We put cardboard down, and then we fill them with straw and food and worms and just keep on going. And eventually the castings fall underneath, and you feed from the top, the worms move up. And vermicompost is some of the best quality compost you can get. You can get bigger bins. This is Bill and Ramsey Cronk at a school garden in Santa Barbara. Bill really is an expert on worm bins and has built many of them for schools. This is Apricot Lane Farms, and they have a 100-foot long worm bin with a mechanical knife that goes underneath it. And they use their compost on the landscape. Here's a worm bin that we have at one of the local schools. And again, it's a continual flow worm bin, and we grew mushrooms under this one. And we're very, very successful growing oyster mushrooms. And the kids loved the fact that the unintended good consequence here, a symptom of working in regenerative systems is unintended good consequences. And we didn't realize that we were going to get salamanders and frogs in our worm bins, but we did. And the kids loved those. And we also were able to grow mushrooms underneath them. So this is some of the brewing. The simplest thing for me to extend the ability of compost to affect your landscape is to dilute it, is to put it in water. And so if you put compost into water and stir it around and make a slurry, then it's going to go further than if it is just powdered, compost. So I encourage you to make extracts. Now, these are actually actively aerated compost brewing, and this may be more activity than you want in your garden, but these have air pumps that pump air through, and function of the air is to disrupt the biology that's on the compost that's in those bags. And so what we're doing is making the compost go out through the 400 micron mesh in the bag and go into the liquid. Actively aerated compost tea. And the beauty of that is that it is liquid carbon. You are pouring carbon on your soil. And you can do this, as you say, this is a 5-gallon bucket. And you could be putting compost in your 5-gallon bucket and stirring it up and add it. You could add some foods or not. The simplest foods would be liquid kelp, liquid fish. The next video, I think, is just some 5-gallon versions of, oops, I like that so much, actually. Here's some 5-gallon ones. Here's some 5-gallon actively aerated
Fungally and
beers.
bacterially dominated composts being brewed under the same conditions, but with different foods. We'll look it up under the microscope tomorrow.
And so this one, you can see the foods at the back I put up there, and the seaweed extract, the liquid kelp, that's something I use regularly. The organic liquid fish, I use that. These ones I don't use so much. The molasses is more suitable if you're trying to grow annuals. If you're trying to grow broccoli and kale and cabbage and those sort of things. And this one is a mixture of, it's fish emulsion. It's not whole fish. This is fish hydrolysate. So I prefer this because I'm trying to grow fungi. And then humic acid is something that I add. You can make your own humic acid actually just by pouring water through finished compost. But humic acid will complex chloramines if you have water that's coming from a commercial treatment facility rather than well water.
Mhm.
This is Corey at Lotus Land with their 100-gallon brewer, just to show you the scale that you can get to. This is me teaching up at White Buffalo Land Trust. This is Halama Canyon, and the brewer here, this is a tote brewer called a GOT brewer, and that'll brew 250 gallons at a time. This brewer, which is a smaller brewer that I use in my garden, this is brews up to 30 gallons at a time. So, you know, 250 gallons is a lot of compost tea, but if you're a farmer, then that's what you need. And that GOT brewer is now being used by folks up in Wasco for an experiment on almonds. What's this one? Oh, that's the brewers that are at Apricot Lanes. They have two 500-gallon brewers there. Here's a way of applying it, just with a sprayer in the back of a truck. This is the pool tanks that they have for applying compost tea at Lotus Land. Here's me doing an application on citrus. I wish I had the after picture on that because the trees were very, very happy. This was on some navel oranges. And so the last thing I would just want to emphasize is the importance of, okay, plants are taking carbon dioxide out of the atmosphere and they're pumping it into the soil. It's so important to provide pollinator support. And so that gets us back to story of our pollinators. And really, native pollinators are great. Any pollinators are good. And there's such a variety of insect life that will come to a garden like this. This is the understory of the fruit orchard at Lotus Land. And to a certain extent, you know, this is cilantro that's gone to flower. And we have to embrace the chaos of nature. And again, the over controlling nature and being scared of chaos this is to insects. This is an easy place to land and get nutriment, you know, and it's so important for the landscape. So the work that you are doing with schools and that we're all doing with schools, I think is really important work. I'll finish with this picture. On the left, is Quinton. He was a sixth grader. He's now an eighth grader, but this was a sixth grader participating in our oak regeneration program. We brought Oaktober to Ventura County. Ventura County proclaimed that in 2022. And he said when he was planting this oak, he said, "This is the best day I've ever had at school." And on the right, we have Charles Darwin. Do you notice any similarity between these children? You know, you just never know the children that you're connecting with, what they are going to develop into. And I think that a connection to nature from an early age is really, really important. So I encourage you to connect with schools, with gardens, with kids and nature. So thank you very much for giving me time to talk to you. I brought you through a lot of different things. I'm very curious if you have any questions, and there's my contact information if you want to follow up.
Oh, thank you so much, David. That was wonderful. Thank you. Actually, you do have questions waiting for you in the
Oh,
chat.
okay. All right. So let's have a
There's a
look.
bunch.
All right. Let's see if I can. I see some new messages.
So I think you could unshare your screen.
Will do.
And I think I'm thinking I'm going to, here we go. I'm going to pause the recording.